Hi kids, in this video we'll be continuing with exercise 8a sums which are left. Okay, come on, let's go to question number 18. Equilateral triangles ABD and ACE are drawn on the sides of AB and AC of triangle ABC. You have to prove that DAC is equal to EAB and DC is equal to BE. Now since it is an equilateral triangle, let's first do the markings. ABD is an equilateral triangle, so all sides are equal and each angle measures 60 degree. Correct? Now AC is an equilateral triangle, so all sides are equal and each angle measures 60 degree. Okay? You have to prove that DAC is equal to EAB. Now for the first one, what is DAC? DAC would be 60 degree plus angle BAC. See here, DAC is 60 degree plus BAC. What about angle EAB? EAB, even that is 60 degree plus angle BAC. So these two are same. That means DAC angle is equal to EAB. The first part is proved. Now you have to prove that DC is equal to BE. DC is this side, that is equal to BE. This you have to prove. That means if you have to prove a side, you will have to take the triangles. Let's take the two triangles. So in triangle, we can take triangle D, we have to prove DC. So DCA, DAC and triangle, you have to prove BE. So BAE. Now let's just take one triangle first so that you are clear with the concept. I am taking this triangle. Okay, this triangle. Now in this triangle, what do you see? In this AD, DAC and triangle B, sides are equal. AD is equal to AB. We have already, this given it's an equilateral triangle, so the sides of equilateral triangle are equal. Then what about the next one? Next one AE, okay, in AE will be equal to AC. Equal sides of equilateral triangle are equal. Okay. Now third, we have already proved angle DAC is equal to EAB. This is already proved. So therefore, triangle DAC is congruent to triangle BAE. By which test? Side, angle, side. So it is SAS test of congruency. What about DC and BE? DC is equal to BE. What is the reason? Corresponding paths of congruent triangles are equal. Okay, come on, let's go to the next question, children. Yes kids, let's do question number 19. Okay, in the given figure, ABCD is a square and PQR are points on side AB, BC and CD respectively, such that AP is equal to BQ is equal to CR. And angle PQR is 90 degree. I have already written what you have to prove. So first let's do the markings. Since ABCD is a square, all sides would be equal, right? And each angle measures 90 degree. Okay. Now what you have to prove? First thing you have to prove PB is equal to QC. Wait. This also you have to mark. AP is equal to BQ is equal to CR. So I will do different markings so that it's clear. Okay. You have, this is already given to you. You have to prove PB is equal to QC. Let's do the first part. Now since it is a square, AB will be equal to BC. Why? Sides of a square are equal. Right? And how do you get, so AB minus AP, you will get PB because that's what you have to prove. Same way, BC minus BQ, you will get QC. Now, these two are equal and in the question AP is already equal to AQ. Therefore, we can say that PB is equal to QC. I hope it's clear. Come on, let's do the next part. The next part is PQ is equal to QR. You have to prove this side is equal to this side. So we can take this triangle and first prove the congruency. So for the second part, in triangle PBQ and triangle RCQ, okay, RC is equal to BQ. This is given in the question. CR is equal to BQ. We have already proved that PB is equal to QC. This we have proved, correct? And we know that angle PBQ is equal to angle QCR is equal to 90 degree. What is the reason? Each angle in a square measures 90 degree. Correct? Therefore, we can say triangle PBQ is congruent to triangle RCQ by which test? Side, angle, side. So, it is SAS test of congruency. And therefore, PQ will be equal to QR. What is the reason? CPCT. Corresponding parts of congruent triangles. Okay. Now you have to prove. Now you have proved that PQ is equal to this. Okay. Now in triangle, for the third one, you have to prove QPR. QPR is 45 degree. So these two sides are equal. So in triangle PQR, okay, let this be X. So even this would be X. Why? Because the sides are equal. So opposite angles will also be equal. So X degree plus 90 is 180, angle sum property. So X will be 2X is equal to 90, X is equal to 45. So we can say that angle QPR is 45 degree. Yes kids, let's go to question number 20. In the given figure, ABCD is a square, EF is parallel to BD and R is a midpoint of EF. You have to prove that B is equal to DF, AR bisects this much and the third part. So first let's do what information is given to you. Since ABCD is a square, all sides would be equal. Sorry, single one. All sides are equal, correct? Then EF is parallel to EF, this is F. EF is parallel to BD by drawing an arrow and ER is equal to RF. This is equal to this. What you have to prove? You have to prove that BE is equal to DF. First thing you have to prove this. So if you want to prove this, what you can do? You know these sides are equal. First if you prove EC is equal to this, you can get this is also equal to this. Come on. And how do you prove it? Now see here. Since each angle measures 90 degrees. This is 90 degree. Each angle measures 90 degree. Now, since these two sides are equal, so these two angles will also be equal. And talking about angle, triangle BCD. This is 90 degree. This side is equal to this side. So, this angle will be equal to this angle. So, the measurement for these two angles would be, so in triangle BCD, okay, BC is equal to CD, equal sides of a square, then so angle CBD is equal to BDC, which will be equal to 45 degree. Correct? Now, these two angles are 45 degree and these two sides are parallel. So, if this is 45 degree, even this angle would be 45 degree. If this is 45 degree, even this angle would be 45 degree. What is the reason? Corresponding angles. Since EF is parallel to BD, okay, angle CBD will be equal to angle CEF, which is 45 degree, and angle BDC will be equal to angle EFC, which is again 45 degree. Correct? Now these two angles are equal. If these two angles are equal, if these two angles are equal, so we say these two angles are also equal. So CEF is equal to EFC. If the angles are equal, the sides opposite to equal angles are also equal. So we can say that EC is equal to CF. So EC is equal to CF. What is the reason? Sides opposite to equal angles are equal. I hope it's clear. Come on. So now we can prove the first part. BC is equal to CD. Okay. BC minus EC is equal to CD minus CF, which is equal to BE is also equal to DF. The first thing you have proved. Correct? Now AR bisects angle BAD. AR has to bisect angle BAD. Okay. So first thing over here you will prove the congruency. You will have to prove that this side is equal to this side. So in triangle ABE and triangle ADF, okay, these two are 90 degree. Angle ABE is equal to angle ADF is equal to 90 degree. Each angle in a square measures 90 degree. Then AB is equal to AD. Sides of a square are equal. Then BE is equal to DF. This is also been proved, right? So we can say that therefore triangle ABE is congruent to triangle ADF by side angle side by SAS test of congruency. Till here it's clear. I'll erase so that we continue. Okay. Now we have proved this. So what does it mean? It means that AE is equal to AF CP, right? AE is equal to AF CP. Now these sides are equal, so therefore triangle AEF is an isosceles triangle. It is an isosceles triangle, and AR bisects EF. AR, so or we can say R is a midpoint. It's already given. R is a midpoint of EF. That means AR bisects angle BAD. See the important thing over here. These two sides are equal. Okay. This is a midpoint. So therefore this becomes the bisector. This becomes the angle bisector. AR becomes the angle bisector of BAD. Okay. Come on. Next part. If AR is produced, it will pass through C. Now let this be point O. If AR is produced, now first thing, AR is bisecting the first diagonal which is BD at O. Correct? It is bisecting BD at O, and it is also BD is parallel to EF. That is also given to you, where R is the midpoint. So in short, we can say that AR is a second diagonal, so it will pass through C. It will pass through C. What you have to prove? We have to prove that AR will pass through this. Now, AR is a bisector of angle BAD. Bisector means the diagonal, right? And it is intersecting the first diagonal at point O. So, therefore, AR, when produced, it will pass through C because it will become the second diagonal. Okay, let's write this. I'll erase this part. Now, we have already written this. Come on. So, here we know that AR is bisecting BD at O, and AR is a bisector of angle BAD also. So, therefore, AR is part of the second diagonal. So, it will pass through C when produced. I hope it's clear. Come on, let's go to the next question. Yes kids, let's do question number 21. ABCD is a parallelogram. Parallelogram means opposite sides are equal. So, this is equal to this and this side is equal to this side. Then angle A and angle C are the obtuse angle. Angle AXD and angle CYB is equal to 90 degree. I have to prove that XA is equal to YC. Okay. So, which two triangles will you take? You will take this triangle and this triangle. So, in triangle XAD and triangle YCB. Okay, what is given? Angle AXD is equal to angle CYB is equal to 90 degree. Reason is given. Okay, then AD is equal to BC. What is the reason? Opposite sides of a parallelogram are equal. Okay, so two conditions you got it. Now think of the third condition. Now, in a parallelogram, the opposite sides are equal as well as they are parallel. So, we can say that this angle Z will be equal to this angle. See, I am drawing Z. These are, since this is parallel to this, so these two angles will also be equal. So, we can say angle ADX will be equal to YBC. What is the reason? Alternate angles. Correct? So, therefore, triangle XAD is congruent to triangle YCB by which test? Angle side. Test of congruency. And XA will be equal to YC. Why? Corresponding paths of congruent triangles are equal. Okay, let's go to the next question. Yes kids, let's do question number 22. ABCD is a parallelogram. Parallelogram means opposite sides are equal. Okay, and they are parallel. Okay, now the side AB and AD are produced to E and F respectively such that AB is equal to BE and AD is equal to DF. Okay, come on. You have to prove that triangle BEC is congruent to triangle DCF. So, in triangle BEC and triangle DCF. Okay, you will take BEC and DCF. What? Look at these two triangles. This side is equal to this side. right? BC, you can start. AD is equal to BC, but BC is equal to DF also. Okay. Same way here, AB is equal to CD, which is also equal to BE. So two conditions, you got it? Yes. Now for the third condition. Now these two lines are parallel to each other. So therefore this angle will be equal to this angle, corresponding angles. So angle FDC will be equal to DAB. We will write corresponding angles. Okay. Now if you take this and this as parallel line, so this angle will be equal to this angle, corresponding angles, correct? So that is also equal to CBE, corresponding angle. So in short, what you got? This angle is equal to this angle. Therefore triangle BEC is congruent to triangle DCF by which test? Side, angle, side. Test of congruency. Okay, you have to just prove that and we are done. Yes kids, coming to the last question of this exercise, question number 23. Okay, in the question it's given that AB, the perpendicular bisectors of the side of triangle ABC meet at I. First let's understand what you mean by perpendicular bisectors. Perpendicular bisector means they are actually like a height, that means 90 degree. They will cut the side at 90 degree, the angle at 90 degree. Bisector means they intersect or they cut the line segment into exact half. So what does it mean? Say if I say BM is a perpendicular bisector, so this is 90 degree, and since it is a bisector, this side is equal to this side. Same way NC, it's a perpendicular and this side is equal to this side. Same way AL, it's perpendicular and bisector also. I have to prove from here IA is equal to IB first. Okay. Then I will prove IB is equal to IC. Okay. So let's first prove IA is equal to IB. So for that I will take these two triangles. So in triangle ANI and triangle BNI. First what is given? BN is equal to AN. It is given in the question since it is perpendicular bisector. Correct? Then it is given this angle is 90 degrees, so even this angle will be 90 degree. So angle ANI is equal to angle BNI is equal to 90 degree. Correct? Then this is a common side. IN is equal to NI, which is a common side. So therefore triangle ANI is congruent to triangle BNI by which test? Side, angle, side. SAS, test of congruency. Therefore, once these two triangles are congruent, I can say that IA is equal to IB. CP, CT are congruent. Corresponding parts of congruent triangles are congruent. This is my first proof that I have got. Now second part. In the second part, I will prove that IB is equal to IC. So you will take in triangle BIL and triangle CIL. BL is equal to LC. This is given. Then angle ILC is equal to angle ILB. Correct? 90 degree. Same way over here. This side is common. IL is equal to IL, common side. Therefore, triangle BIL is congruent to triangle CIL by which test? SAS, test of congruency. Correct? So that means IB is equal to IC. Same, CP, CT. This is the second part. Now I combine both this. So when I combine both this, I can say IA is equal to IB is equal to IC. I hope it's clear. Yes, student. So we are done with the first exercise of triangles. I hope you understood, and please stay connected for the next of my videos. Thank you.